Hi everybody, welcome back to Exploring Trigonometry. Last class we introduced you to what trig was all about, how to name the sides and what the three trig ratios are. Today we are going to start right there. But as the title gives away, because I can't keep secrets from you, we're going to be learning how to find lengths using trigonometry. So we're going to begin by reviewing how to name a triangle. So there are three sides to a right triangle. The hypotenuse, just like was in the Pythagorean theorem, it is the longest side, or the definition I prefer, it is the side across from the 90-degree angle. If your angle is in one spot, the side that's across from it is opposite, and the one that's beside it is the adjacent one. And notice that if the angle changes, so in the triangle on the left, it's in the top right. In the triangle on the right, it's on the bottom right. The names change, okay? So the longest side of a triangle and that is opposite to the right angle, where to go? The hypotenuse, the side across from the triangle of any given angle. So if we have this angle, the side across, opposite, and then the one that's beside or helps make the angle. So the hypotenuse is always one side of the angle, and then the adjacent is the other, adjacent. Ratio is a fancy way of saying things that are divided. So if we do opposite divided by the hypotenuse, that is the sine ratio. The adjacent divided by the hypotenuse, that is the cosine ratio, and the opposite divided by the adjacent, that is the tangent ratio. We're used to looking at it this way. Sine theta is opposite over hypotenuse. Cos theta is adjacent divided by hypotenuse, and tan theta is opposite divided by adjacent. Now, if we look at these letters, then this gives us that acronym that I introduced you to the other day. SOHCAHTOA. And for all three of them, it gives you which trig function it is, and then what's being divided by what. Now, when you're finding lengths, you need to have a right triangle. But as I said last class, sine, cosine, and tangent ratios is a way of connecting lengths to angles. So we can use them to find missing lengths or missing angles. Now, if you're looking for unknown length, you must know an angle other than the 90 degrees and at least one of the lengths. All right, so here's an example. So let's find the length of x. So we're going to start by finding the angle, finding a angle. And in this case, 25 degrees. So that's simple enough. We got to name the sides. So the reason that we have to find the angle to begin with is we got to use it to name the sides. Since this is beside the angle, it's the adjacent. And this is across from the 90 degrees, it's the hypotenuse. So if we think, I don't know why I keep putting an H there, TOA, which one of these three trig ratios has adjacent and hypotenuse? So we've kind of mashed 3 and 4 together, right? We named the sides, adjacent, hypotenuse, decided which ratio. Since we are looking for the adjacent, we have the hypotenuse, that must be the cosine, and then we set up the equation, which is just fancy talk for write the equation down. So just like everywhere else in math, once you have your equation, substitute the values in. And then solve for x. Notice I'm working to 4 decimal places. Well, today it's not essential, but it is a good habit to get into. Tomorrow it will be essential, so you may as well do it now. Finally, we're going to take it. The question doesn't say how many decimal places to solve to. I'm going to assume it's 1 decimal place, so round it to the appropriate number of decimal places and add your units. Now we're going to work a little closer to what I'm going to expect. We're not going to get all the way there, but what do we have? We have the angle over here, which now makes the 17 the opposite, and the hypotenuse. So thinking back to our trig ratios, opposite over hypotenuse is sine of A Now remember, for division, order matters. Where we go? Now in a minute, I'll show you what I expect on an assignment, on a test out of your homework. Right now, I am showing every step because I want you to know how to go through this process. And again, rounding to 1 decimal place, just to be, well, just because I almost round everything to 1 decimal place. All right. So give it a shot. And remember the units. As always, pause it. Now, my 2 examples, I went through everything. Here's what I'm expecting out of you. So you don't have to write down what sides are what. You don't even have to write down the formula that tan A equals opposite over adjacent. Some teachers require that. I am not one of them. However, and in my case, I'd like to think that your algebra is good enough that you're just jumping right to this, that you can isolate C without having to show me all the steps. Okay. That is a terrible 17. I'll fix it later. Now, I want you to notice I did this step right in my calculator. So I typed in 17 divided by tan 53. So I don't have to write down the 4 decimal places. If my calculator does everything for me, that's even more accurate than the 4 decimal places. What is this? This is sine 37. All right. Okay, guys, that's it for the lesson. I'm sure in real life that you probably would ask me for 1 or 2 more examples, but I'm hoping that's good enough. Worst comes to worst, replay it. But the gist of it is find the angle, name the sides, set up the equation, fill in the values, and then use your algebra skills to solve. Here's your homework. Good luck, guys.